We're going to be doing Ratey number 2. This is the topics we're going to be covering. We're going to be covering holes, aka points of discontinuity, writing equations from graphs, and we're going to be doing question 2 and 9. Now, if you go to my website, I have more problems worked out. It's just that I feel like these need to be explained on video. The first question we're going to be doing is number 2. We need to factor the numerator and the denominator. Factor out. It's going to factor out as x minus 3 and x plus 1. And then we're going to factor the denominator as x minus 6 and x plus 1. And what's going to happen is we have the same factors on top and bottom, the x plus 1s. And it doesn't matter what x is. You can let it be anything you want, like 100. You'll get 101 on top and 101 on bottom, and they're always going to cancel out. So we need to cancel them out, which is great because it makes the mathematics easier if there's less stuff there. We just need to make sure that we remove that point at -1, because if you let x be -1, this right here is 0, and you cannot divide by 0. So that's why we need to create a hole or a point of discontinuity to remove dividing by 0. All right, now we're going to do r. So we set the top equal to 0. We get a root of 3 comma 0. Then we're going to do our asymptote, set the bottom equal to 0. We get x equals 6. And then we're going to see the multiplicities of each factor. And each factor is only to the 1 power. So that means there's no double answers. So this is none. In most cases, it will be none. But you're just looking for double answers. And then E is end behavior. We compare the degree, which is the highest exponent in the top and the bottom. Both degrees after canceling is 1. They're the equal. So we're going to divide the leading coefficients. That's a 1 and a 1. So we get y equals 1 over 1, which reduces to just 1. So that means we have an end behavior or horizontal asymptote at y equals 1. And then finally for the y-intercept, we let x equal 0. We get -3 divided by -6, which is +1/2. All right. And then I do want to indicate that point of discontinuity, that hole at -1. So I'm going to say that there's a hole at -1. So I just need to remove it. And now we're going to graph it. Let's put our asymptotes in. Our asymptotes are going to be at 6. 1, 2, 3, 4, 5, 6. That's a vertical line at x equals +6. And then we're going to have a y equals 1. End behavior. And then we have our root at 3, 0. 3 comma 0. Okay, so now all we have to do is go towards the asymptotes or zeros. I'm going to start, oh, and we also have our y-intercept at +1/2. So it's going to go like this towards this end behavior, and then it's going to go towards this asymptote. I'm going to do that a little bit thicker in black so you can see it better. Goes through 1/2, goes through 3, and then there's no togetherness, so it's going to come back up here, and it's going to go towards the end behavior. And that is your graph, but we're missing one thing. And this is the whole reason why we're doing this problem. We need to remove the point at -1. So at -1, we need to take that point, and we need to remove it. So what I've done there is I've just taken that 1 point out, because then I would have divided by 0, which is a big no-no. All right, that's number 2. It's the first one with a hole. If you take a look at your work, number 5 also has a hole. There's a few other ones, but make sure you do number 5. Let's take a look at number 9. All right, for number 9, we're going from a graph to the equation, so it's working in reverse. The thing that I'm noticing is where my roots are and where my asymptotes are. So that's your R and your A, and then the E. So I see that I have a root at 0, and I have an asymptote at 5, and y equals 1. And let's start with our asymptote of x equals 5. By the way, your graph doesn't have the red on your assignment. You can just see by where the line goes that it's at 5. But I need to make my denominator be x minus 5, allowing for the x equals 5 asymptote to exist. And then I have a root at 0. So that's just going to be an x up here. Now, let's say it was at positive 3, it would be x minus 3. But it needs to be 0, so it gives me that root at the top. And then this end behavior is at y equals 1. So I just need to make sure that my degrees are the same. Luckily, it is the same, and that's it. Now, notice that our end behavior was y equals 1. Let's just say it was y equals 1, 2, 3, 4, 5. What I'd have to do is I'd have to put a 5 right here, multiply it, vertically stretch it out. And what that would create is that would create an end behavior of 5 to 1, which would make it y equals 5 over 1, and thus give me that end behavior that I needed. All right. There's more of these questions that look like number 9. I've worked out one more, number 11 on the website. I would take a look at that and make sure that you're getting it right. All right, guys, message me if you have any questions. I hope to see you guys soon, and take care. Track 6 is bad.